So it seems, I think the majority people are interested in such that I will just very briefly not cover Buildbot itself much at all, and then go into the specific improvements done here. So the Buildbot is a server that you can use for testing and packaging. So the typical setup like they do in MariaDB, when you have a repository in-house or on Launchpad or in GitHub or wherever, it can monitor this repository. I think in MariaDB you actually get an email from Launchpad where it says that this is a new commit, and then your Buildbot server, then Buildbot is let's see now. This is a typical Buildbot setup. So when Buildbot master sees that okay, there has been a new commit, you have configured basically these are shell scripts or Python scripts. Combination of Python scripts and shell scripts, which tells the Buildbot what to do. And then you have a farm of slaves, and this is to distribute work. Some of these tests can of course run for hours, but another good thing is that you can have different operating systems and different versions of Ubuntu and Red Hat and Windows and everything. So you have a big farm of machines so that you get good test coverage in different environments. So the Buildbot master sends these recipes to the slaves that please now run this test suite. They can be short or long, or they can be about packaging. My favorite is when you do all of the packaging and then you also test the packages. So traditionally many people had a test suite and the packaging. If, for instance, if you use OpenSUSE build service, you can run make test and then you can run the packaging, but you cannot actually test that the packages work. This is why I didn't use that system, but I continued using Buildbot like we had done in MariaDB. But
you can also test upgrades.
Yes, so you can test all kinds of installations once you have the packages built. And I don't actually do that here. So this is not a complete system, but there are many enhancements that are complete that you can use, for instance, back in MariaDB. Okay, so we had a page here and wonder where it went. So this URL is something that actually works. It's from MariaDB, and the main user interface to Buildbot, I would say, is this waterfall page. So on the left side, and there are two open source projects. One is called Hudson. So now it's called Jenkins because there has been this kind of Oracle also owned Hudson, and then they started calling it Jenkins instead. And then there is Buildbot based on Python, Jenkins based on Java. Drizzle used Buildbot and moved to Jenkins. You used Jenkins and say you want to move to Buildbot.
Why?
So yes, I have absolutely no understanding which one is better.
Because of the uncertainty of what's going to happen with Hudson and Jenkins.
Okay.
What uncertainty? Isn't there like a community around Jenkins?
Yeah. But you know, whenever something like that scatters up, and let's see, we are considering this.
Yes. So you have vertically, you have like a timeline how the batch jobs run. And here we need to scroll a little bit. So MariaDB has many builders. The builders are the kind of jobs, the scripts that you have specified. And down here you see you don't actually see the so one job could run on many different slaves theoretically.
Do quickly and see the build log.
So if you click on one of those, you can see the Oh, there are even pending.
And where
And at the end you see build slave name where that builder belongs to.
Yes, but there could be more than one build slave for the same job.
The same builder?
Yes, because it's plural.
Yeah.
But you don't use it that way. I don't know how that would work.
Yeah.
we don't have the repetition.
Yeah, when you click on the slave name, then you'll see all the builds for the slave.
Yes.
Sure.
So these are the three different views.
That's a good example.
So this is build slave is now a physical machine. This Adam Dutko is like a community guy who donates some server time from his servers, and then you run your tests on that. Okay, let's go to so this one is not. This is a server I have on Amazon, so it's running now, but you cannot generally access it. And this is what it looks like. So on different builders at different points in time, you see some works happening.
Yeah, unlike MySQL later than Sun and Oracle, we have a system for testing builds and separate build team to actually build releases and packages.
Yeah.
We actually have all the packages built in Buildbot, and when we just want to release them, we just take the latest devs or RPM from the Buildbot, and that's what we do.
Yes, there's no smoke testing.
The keyword here is automation, and Christian and MariaDB is really a guru on this. So in MySQL we used to have all these emails like, we have now created builds, could everybody please stop their work and install this on all kinds of machines? And this is bullshit. You cannot have 400 people who should just jump and smoke test your stuff. So Christian in MariaDB basically automated all of this. And every time you commit, I don't know if you do it every time, but theoretically you could for each commit go through all of the different packaging for Windows and all the Linux systems. And test them as much as you want, and you know all the time that all this process works, and once you are finished with that you actually want to release something, you just take the output of this process and you know that it's very well tested.
No, but that's, we have Buildbot and build devs, and we test that they install that testing.
We test install
We
upgrade.
test installation and that's
Yes.
Yeah.
And devs from every build, they are published, so you can basically go to any build, find the corresponding dev, and you can go.
Yeah. So the first thing I did when I wanted to work on this, I don't have an employer, so I cannot just buy 10 powerful servers on my own money, and I was kind of interested in Amazon anyway. So virtualization is good, and actually MariaDB also uses virtualization. So you have Christian has a large server in Denmark actually, which internally has many KVM images. You have more than 70 now, I hear. So you have one which has nothing MySQL. First you have the one that's building MySQL, then you have one that has a basic Linux system and you can test whether installation works. Then you have one which has MySQL 5.1 and you can test whether upgrading works. So and for each version of Ubuntu, every 6 months you have all of these. So you quickly get a lot of images.
Something with Windows too.
Yeah, now there's Windows also.
Yeah, Windows, Solaris, everything you want to support.
And the good idea with images that after you're done with building testing, just start from the old image so you don't have all the changes done. Nothing can hang during the testing, like log out the whole Windows, you just kill the virtual machine install from old.
Yes, so you always start from a clean save state.
You don't need to do any cleanup, nothing.
Traditional Buildbot, and Buildbot is pretty good at it, so it deletes the working directory you did, and probably it starts from a clean state every time. But this kind of where you have a read-only virtual image, it's very good. So you know that you start from a clean state every time. I think especially on Windows this used to be a problem where the previous runs would leave some garbage and then you had errors the next time. So this is good. This is a good use case for virtualization. Now if I want to use Amazon, So Christian developed something where he had like normal Buildbot scripts, but then as part of the testing and part of the packaging scripts, he also had he developed a small utility that will launch virtual images and log in via SSH and pipe. You actually then need to copy also the MySQL stuff and log files in and out of the image. And then it will pipe the kind of actual testing into the virtual image and then see what happens there. And it's quite convenient, but basically all of this managing of images is visible now in the Buildbot script. So all of the MariaDB tests, except for some of the basic ones that you had in the beginning, all of the MariaDB tests actually have all of this virtualization stuff hardwired into the testing scripts. Now if you want to run this on Amazon, it's not possible because it's not, you cannot run, the cloud is already a virtual server, so you cannot run, and it doesn't make sense to run more KVM images inside an Amazon server. So the first step was to take this and make it run on Amazon. And actually this has been done, so there exists in Buildbot itself a class called EC2 latent build slave, which is just like the normal Buildbot slaves, except that the servers are not running. So it's a class that will basically lie to the Buildbot master that I am a slave and I'm in connected state and I can receive jobs, but actually the server is not running. And then when you submit a build, the first thing that happens is that this subclass, so it's a different type of build slave, will then use the Amazon API and send HTTP commands to start the server. And once the server has started, and it connects, and the server is supposed to have to be an image which has Buildbot installed. So this is a difference also where MariaDB has only one. MariaDB, this big machine is a Buildbot slave, and these images don't have anything to do with Buildbot. You just SSH into them and do the stuff from the outside. Now in this system, the slaves are again, which is more like the classic way to use Buildbot. All of the images you create must have the Buildbot slave installed, and they must know how to connect to your master. But the good thing here, two things. These servers are not running, so you save money on Amazon. They just launch when needed. So for me, when this is a hobby project and I do it at night or at weekends, it wouldn't make sense to have servers running 24/7. The other thing is that once you actually do builds, you can start many of them in parallel. So Christian has all of the different operating systems on one physical server. So I think he runs like 2 jobs in parallel. So for you to publish all of your different supported operating systems, it takes at least 24 hours to go through all of these. Whereas in the cloud, you can just launch 70 different parallel slaves, and you can decide whether you use the minimum instance or the large instance. The minimum will take 4 hours, the large instance will take less than an hour to compile, and then you're done.
4 hours to compile?
On a 1 CPU machine.
Seriously?
At least 2. It has changed. So in the beginning it also used to take 1 hour to download the sources from Launchpad. I have fixed that. Yes. So you save money. The other thing is that this now goes back to the classic use case of Buildbot. So my builders in this system are normal. The test scripts only contain the actual testing stuff. And the stuff that starts and shuts down these images is in Python code in a Buildbot subclass.
Can you in Amazon do this thing like this as a Buildbot, like you start from read-only image to something, then you throw everything away and start your previous version of the image?
Yes, actually you cannot save the image. Yes, okay, you can stop a server and start it again. But what you do here is that you create an image and you start it from scratch every time.
Okay.
How much does one build cost you, and how many against how many platforms?
The builds, I only had
There's 6 platforms.
yeah, I had like a few Ubuntu platforms, yes.
And what does that cost you, like in real dollars?
But the development time is what costs. Because every time, so for instance, last night I fixed this final thing that I never got done.
Yeah.
I think I started, I had to restart the slave 12 times or so, and for each time you pay for a full hour. Even though I didn't actually work 12 hours. So I paid, during January and February I paid a few $100s each per month.
Per month?
Yes, but now during March I think I paid $3.
So maybe it's cheaper, for us it's probably cheaper to still have Buildso.
No,
Yes.
I don't think so.
Yeah.
What instance type do you use?
Not doing it much.
In the end I used large. My situation is that I'm a dad who has a okay salary. I'm not a student anymore, and I also have kids. So it makes sense for me not to wait 4 hours for a build to finish. I can pay extra to work more efficiently.
So the 4-hour build, what kind of server is that? I'm not.
That's the smallest,
It's
cheapest.
got like very low CPU. And
Yeah, it's one very small CPU.
And it's only 3 US cents per hour.
And the large one?
It's 44 per hour.
Okay.
Yeah, 44 cents per hour. It's significant. It's a big difference. It's more than a 10x difference
So it doesn't,
between the micros.
builds in 10 minutes and you have to pay the whole hour anyway.
Yeah.
So it should be like in 4 hours or at least in 1 hour.
So for working out the bugs, it's better to stay on the micro instance, and then
later.
once it works,
Okay.
Now, what I don't have a picture of, because that's what I finished last night. And actually I had already created a full system that did this, and I was going to publish it a week ago, and then I saw that this system already exists. So now I ported my stuff to use the existing system. So the other big problem that Christian always complained about is that managing these, this is good for running the stuff, you start and stop images, but managing these images becomes painful. So maybe you don't want to have the initial resource on an operating system, but you would actually want, because people run get upgrade, so you actually should test about like the most recent upgraded system. Or you realize that actually we have a new build dependency or something, and then you need to insert this into your 70 images. And Christian complains about it, but on Amazon this is even worse, because on KVM at least you can make the images read right and go into them 70 times and do some change and then save them. On Amazon you have to create a new image, take a new snapshot. You cannot save the image once it's created, so you have to take a new snapshot. It gets a new snapshot ID. You have to copy this ID into all kinds of places where it should be started. So you don't want to do that. And I was glad now to see last week that other people have also thought of a solution to this. So Amazon has a way to give input to your instance when it's running. This is called user data, and the website that has now the official solution, and I'm not going to publish my thing that did the same stuff, is called elastic.com. They have all kinds of Ubuntu and Amazon stuff. So what user data does, you can copy-paste, if you use the web user interface to Amazon, you can copy-paste some text, and this text is made available by HTTP essentially. So you can use curl or wget to fetch this. It's like a static IP address that you use. I could maybe show it here.
But then you need to do it every time you start an instance for
Yes.
every build.
So what is the IP address? It doesn't say. Let me check. It's it's here.
In case the setup package is already you have package like on server host and when you release it, you just have
They have something Sardinia for creating what do you say? That's the task.
yeah, I've seen them. How does it differ? How is it different?
Okay, so it's this kind of magic number. The IP address is always the same.
It's a separate application.
Then we go back to the image. So let's do. Okay, got something there. No, this is good, so it has to have the slash. Okay, so you have this is like a simple REST API. You have this IP address, and then you have versioning, so you can version 1.0 or you use normally latest, because the official versions never have any cool stuff. Then you have two directories like dynamic and metadata and user data, so it lacks, it doesn't actually have a new line there. But so what we want to access is the user data. So then you just add user data. Now, oh, it's not the directory. It's not found. So actually this instance doesn't have user data. But what you get there is then the text document. So what these guys at Elastic have done, what I thought that, okay, I can pass like a script name and then I have some place on mapsql.org or somewhere where I can download shell scripts and run them. But actually what they have done with Elastic is that if you just copy paste the shell script into the user data field, and it starts with a hash and exclamation mark, then it will just execute this script and you can do whatever you want. Then what they still end up doing is that it makes sense to have some web server somewhere where you manage your web script, so that this script that you copy paste is relatively simple. So you can basically use the one that they have here. No, not this one. Yeah, they have a separate article about what you might be doing then. And they also created this kind of utility. So what I do now in the new version, first I get this utility called run URL, which I must also download from with wget first, and then I can use run URL to execute shell scripts that it finds on some at some URL, which is my web server. Okay, so what this makes for us to go back to this picture, I'm developing my own MySQL fork. I take in stuff from Callahan's Facebook patch. I realized that I now need to install something. No, actually it was our Delta had some dependencies that were not easy to spot. So as I get further in the development process, I get errors because something that is needed for the build process is missing. If I'm now Christian managing the MariaDB stuff, this means I have to install this stuff on 70 different images. Instead, I have a set of Ubuntu images that are just normal Ubuntu with these elastic.com modifications, so that if I insert a shell script in user data, it will run it. So I use this to fetch another shell script on my website, which has basically a lot of comments: apt-get MySQL build depths, apt-get install Buildbot, apt-get install whatever, I don't even remember. Then I just go to the script. It even, I think even configures Buildbot. So the other thing I have to do is to pass in what is the address of my Buildbot master. So the slave has to actually call back once it starts. So it even configures the slave, starts the slave, and then the slave connects back to the master when it's running. So at this point, instead of having to manage 72 or 100 images, I just insert one more line. I also want to apt-get install this new dependency, and then the next time I start my Buildbot process, this will be there. So this, even just for my small project, using this kind of system was a huge payoff for me. And this is the main thing Christian complains about. Like, he has most of the stuff automated, except when you need to install something on the images. Okay?
I guess it's not always just an apt-get away. Sometimes the RPM away on Windows.
You need to have a separate then for RPM, but it's still way better than doing it manually 100 times.
Why don't you use something like Puppet or Shell?
Yeah, so the other alternative would be to kind of, even without these systems, you could just have a script that uses SSH from the outside. So you start an image, and then with SSH you kind of go in and install whatever stuff you want, or you have Puppet in these systems. This just seemed like a simple way to do it in Amazon, because this user data stuff is pretty simple. You have a shell script, and that's it. If you are familiar with something like Puppet, sure.
Yeah, and you have also overview what happened, what failed during the install, what not failed, which version it is, and this factor you can see, for example, all my build would have, I don't know, GCC which version, and they return to you what version they need, and which is quite handy for.
So also in this with these elastic scripts, so previously they would output syslog everything that you do from this script, which pollutes your syslog if it's long, but it's still very good. So now you actually need to insert some bash p something command so that you get your own log files. This is very important. I once had one of the biggest problems, and the problem here is that this Buildbot, this abstract build slave class, will also shut down. So if the build finishes after 20 minutes, it will shut down. So if you leave a build running and you see that nothing is happening, you log in and you try to troubleshoot, then suddenly the image will just shut down. So it's good to have good log files and copy them out of the image and see what was happening. The best log file I had was when I did cut on my log file, and inside the log file there was like a dialog saying, please give some configurations for postfix. Because postfix, even if you use the quiet parameter for apt-get, postfix will still ask you questions, and you need to have this Debian front end environment variable set to something so that it will be silent. And that was kind of difficult. I looked at the log file and said, why is there a dialog box in my log file? That's how it worked. But then I knew what was wrong. Okay, so this is this is not Buildbot specific. For anything you do in the cloud, having this kind of system where you don't need to recreate your images all the time is very, very beneficial. It's one of the best things you can do, either with this user data or with some management system. This is much more lightweight. If you haven't used Puppet, there is no reason to learn because of this. This is usually, like my shell script is maybe 15 lines, 20 lines. Okay, what else should we talk about? Maybe we should do a demo.
Is there a reason why you continued going with Buildbot and didn't choose, say, Jenkins?
Yes, I wanted you to be able to benefit from this.
We could also benefit if you had migrated to Jenkins. We could also benefit from migrating to Jenkins.
Yes, well,
I spoke to Brian Aker, the Drizzle guy. He was like, you guys basically followed what we were doing, and now we moved to Jenkins, and it's so much better. It runs. I don't know why it's so much better.
I don't have an opinion on that.
Okay, so you didn't check it out.
Remember that I started. No, I just said that I will use the same thing as MariaDB. Remember that I started doing this in October.
Yeah. So I'm curious to know if Jenkins is better. Or...
I have not looked at it at all. Okay. Let's do a demo. So I didn't actually configure this this stuff where you launch automatically on commit. So I just manually start stuff here from the website. And the easiest thing is just to even if you are committed new stuff, you can just restart an old build and see what's happening. So now what happens here, and this is an interesting phase. So this is something you never see in a classic Buildbot system. This builder is now building, but actually there is no activity here. So there is no output yet, and this never happens in the classic MariaDB. And this is, I would like this to be better. So what is happening now is that this abstract, this latent build slave class is lying to Buildbot that yes, I'm here and connected, but really in the background now it's busy to start a new Amazon server. And that's why even though Buildbot thinks it's building, it's actually not outputting anything yet. And this part takes about a minute or so. So installing, I was a bit worried that does it make sense to start a clean Ubuntu image and then every time you install a lot of stuff to do whatever you want to do. Actually it's pretty fast because they have Ubuntu repositories in the Amazon data center. So it takes like 1 or 2 seconds to download as much packages you want. And then the actual unpacking of the gzip in the packages and the configuration takes a minute or so, but it's still very useful. So what I would like, if you look at these builds here, what I would like to see when a build starts happening, this, in my opinion, this class, even if I don't have such a step in my tests, I think it could output one step where it says I'm starting to serve. And there's also no error message. So for instance, last night when I was still tweaking this to use the elastic variant of this stuff, when you get an error, the only way that you see this is that nothing happens. So Buildbot master is just waiting for a connection, but if you don't get a connection, you don't know that it's not there. So you get a feeling for how many minutes you are supposed to wait before you should expect to see something. I think there will still be some time, but then the build continues normally, and in the end the image is shut down. So the only place, of course, you are also interested to know that you don't suddenly have dozens of images that will cost you money, or dozens of instances that will cost you money. I never had problems, unless there is a problem on the startup, then you need to log in and see what's going on. But other than that, I never had problems. And then the basic, so testing, QA and packaging is a very good cloud use case in my opinion. So if I now was supporting 20 or 30 different operating systems, I could package all of these in parallel, unlike MariaDB who has to do them on one physical server in sequence. So it's a trade-off. Of course, in MariaDB, on the other hand, you have full-time developers and you all the time have some QA going on. So if you had like 24/7 activity at a cloud provider, that will also cost you money. So it's a trade-off. But personally, like I said, I have small kids and I have to spend some hours each night that I can do some hacking. So whatever time I can save is valuable for me, and I'm happy to pay a few dollars for having 24 parallel servers doing the stuff. Yeah, then I think we should move to talk about like what happens more specifically with the MariaDB builds. So where do we have this nice image? This one. So actually producing a MySQL build with this system, you realize that that you have. I think there is another. No, I never did that image. I didn't publish it, but I also had an image where, okay, so C was invented in the 70s and make was supposed to kind of help you build stuff. So that was invented in the 80s. But then even with make, different operating systems and configurations, different libraries. So then you have all of this auto tools monstrosity developed in the 80s and I think mostly 90s, which make your make files more adaptive to where you happen to be building. And then, for instance, in MySQL, you still have a script. You still have scripts that run the automate commands for you, and even you have a script that will do the tar packaging and make for you, which is basically a make program also.
There are no other tools in 5.5 anymore. There are no other tools in 5.5 anymore.
Yes, and I don't know much about CMake, but I'm willing to bet that removing auto tools is an improvement.
Yeah. So.
Yes.
Well, it's not an improvement on itself. I personally have an improvement on other tools, but at least they don't need to maintain two systems in parallel. CMake was used like for 5 years at least.
Yeah. So that's of course. So I haven't heard that CMake would be great either, but most of my problems came here because if you hit a problem in the build, it's very difficult to, like, unless you have worked 10 years on the code base, it's very difficult to know from the outcome of automake or autoconf rather, whether it's a configuration problem or a make file problem.
You know, I think CMake in this regard is much worse.
Yeah, that's unfortunately might be.
This is like a VI versus Emacs question.
Yes.
Maybe other tools they create
you should use
detailed logs. They create detailed logs and you can see what happens in the logs, other tools. And they can do help and do lots of stuff to see what's going on. And in CMake, I didn't find anything like that. Maybe I was just didn't look at it.
So it's another system which you can only use when you have used it for 5 years.
Maybe.
Actually, I think the learning curve with CMake is different from autoconf and automake. If you're new to a project and you're adding a new platform, with CMake we found it much easier than with.
No, I like how it works. I like that I don't need a second system to maintain. I like it builds actually faster. That's my impression at least. It does nicely count percentage. It has global dependency graph. There's no recursive make. There are lots of nice stuff in that, but I found that when something does go wrong, it's much more difficult to find out what went wrong than afterwards.
So that's one thing. I understand the basic idea that, okay, instead of having a constant make file, you do some auto configure and it does some changes for you in the make file. That's fine. But why do you need to have like 5 passes of changes? This is crazy.
You don't just run one tool which does everything for you. as auto recon, which just helps.
Yes, maybe so, but this was messy. This was out of all the layers here, this one I don't like. Then you have different stuff to create tar files, Debian files, RPM files, Windows installers, and in the kind of MySQL forks world, this started with our Delta. So even in MariaDB you build on the our Delta packaging scripts, and I used the MariaDB scripts. And I think, I'm not clear on the history, but I think there is some relationship between Percona and our Delta. I don't know who copied from who.
Sure, our Delta stuff will
You mean you say Percona, they're all branch of Baker scripts, branch from all that, and they also become a script?
No, not quite, but maybe there is some ancient relationship. Okay, and the bakery, our Delta bakery scripts are similar to what most Linux distributions do. So most of the packaging in Linux distributions is done in a way that you have an open source project which cleans a source tar file, and this is the input for packaging. And this is also how MariaDB and I did with my MapSQL project. So this way you actually get a chain of Buildbot recipes. So first you have a Buildbot job that produces a source tar file, and then this triggers the next one, which will test the source file by compiling it and running make test. And then you trigger more jobs that will package it into various binary formats and test those packages.
Excuse me. Does this picture mean that you call build script from a bakery, or you just call out code with the characters?
I call bakery calls different. Bakery includes different scripts.
Yeah, but doesn't
that
you
call
have bakery and then you call build script. Do you call build script or you just call out code from the bakery?
So there is a tool in. So in MySQL you have this script slash.
Yeah, but I mean for building like a Debian package from the bakery.
I think they call one of these. They call out. I do basically the same thing as MariaDB did when I copied this. Okay, but anyway, so that's why you have an extra layer, because also when our Delta was created, MySQL wasn't really using Launchpad yet, or they at least didn't benefit from that. So the idea of having a separate set of scripts is that it's like completely separate activity where you receive the source tar file release, and then you build various packages out of that. But our Delta was still a very manual activity, so Arjen would be up at night logging into different Red Hat and Debian servers and build these packages. So then Christian created for MariaDB this automated layer in Buildbot, but he still maintained this layer of what I call bakery scripts. Because our Delta in my mind is like one of the forks or variants of MySQL, but bakery is the generator.
I think it's worth noting that our Delta really stopped building binaries for.
It's a historical
thing
that lives on in these scripts.
I think sometimes last year they stopped, early last year.
And by the way, I am unlikely to, I think this was an interesting project, but I'm not really kind of promoting MemberSQL as something people should use.
So now you're going to look at MariaDB again.
Maybe not, I don't know. We will see. But at least I created a platform where you could do stuff in the cloud without owning servers. Okay? So if you look at all the things going on here, so at least this layer could go away. So now that we actually, when we create variants of MySQL, we don't really need the source tar file from Oracle, rather we just make a branch on Launchpad. So actually most of this stuff, how to build debs and RPMs, could be pushed into the MySQL sources. I don't see why tar file is the only kind of official thing you produce on the R&D level. and why packaging would be a separate level. Maybe that's because historically Linux distributions had this.
You require to produce the top file because a lot of packages require to actually get the package from the website and then only build it. And
yes,
this
but
is build systems for both Fedora and
yes, but for a project like MariaDB that produce, and most projects, even if Linux distributions also package them from their new releases, they want to produce RPMs and devs. For me, the natural thing would be that all of this should be in the same source repository. And then you have a Buildbot layer which is kind of aware of how many servers do I have and what domain names do I have and who does what kind of testing. Would be a separate layer. But there are too many layers here. Also in the auto tools there are too many layers, but I cannot fix that. What was the last thing? Yes. Now when we have MySQL, and by the way, Percona has their, if you look in the ExtraDB plugin, they have their deb and RPM scripts inside.
We provided support files as well.
Anyway,
yep.
So the final thing, now we have MySQL, Percona server, MariaDB. Drizzle is kind of too different to be relevant here. I had my own name. Facebook has the Facebook patch. So you have many versions of the same code base that need to use different package names for trademark reasons and even just so you can distinguish them. So it turns out I played mostly with the debs, but I think for RPMs you will find the situation is similar. They are very much built around the assumption that the package name doesn't change. So you are not supposed to use the same script to build MySQL one day and MariaDB the other day, even though the content of what is being packaged is exactly the same. So in this one is more interesting. Yeah, so the dev process is much worse, and it has weird stuff anyway. The process of building devs has its own layers of historical stuff that are not really useful anymore. So actually, the dev packaging process, you have multiple files that contain the name of the package that will be produced. And then inside these files you also repeat hard-coded the package name many times. So one of the things I did to play around with this system was essentially to first of all try to harmonize. So the original Our Delta has separate scripts for Debian and separate for Ubuntu, because you can just copy them from what Debian and Ubuntu are doing and build on that. But they do mostly the same stuff, so I tried to merge them so that the same script would be used for all of them, and it worked fine until Ubuntu stopped using these init scripts, and what is the new Upstart? Yeah, so that is bad. But other than that, it would work fine. Okay. And then what I did, I actually took out all these package names. So I have like a generic string called like X MySQL. So essentially I recreated all of the stuff I hate in AutoConf and Automate, and I do the same stuff here. So then you can give as an input parameter whether you want your packages to be called MySQL or MariaDB or Percona. So if you want to take these improvements back to MariaDB, you could then talk to Percona and say, hey, why don't we use the same build system? It will be easier for all of us.
Yeah, do you know what build system Percona uses actually? You're from Percona, I catch it. Oh.
Yeah, there isn't public information on that.
I don't know.
I don't see any public.
From the development team, so I don't know how it works. So.
Okay. I think this might be, and I have consumed my time anyway. I don't even know
see
when
anything public about what Percona uses to build their stuff.
They produce builds. I'm sure they have
Oh, yeah,
a
of
system,
course.
but it's in-house.